So for my physics experiment, I filmed a pool ball going across a pool table. I started it right after the pool ball was hit, and it ends just before it hits the table. As you can see on the top right, it goes relatively linear at a constant velocity. So using the data on the bottom right, I made a model with Python. It also gives a similar result, showing the linear model constant velocity. The difference between the two is represented by this chart here. The experimental being the blue dots and the line being the model from pink dot to pink dot. You can see that the blue dots are slightly higher. I think it's because there was initially the Fnet was not 0 because of spin on the ball, but eventually returned to 0 and went more linear. So what if the origin was different? So let's say the origin was over at the start of the pool table instead of at the ball. The pool table's edge is about 0.4 meters away. So F initial, or F of X initial, would be 0.4 because it'd be 0.4 away from the origin instead of 0. So if we look at that, you see that the same graph comes up, only it's slightly higher. The y-intercept is at 0.4 instead of at 0. So what does this mean? It means that Fnet was 0 for the rolling of the ball, which means the velocity was constant. However, as I said earlier, because the velocity clearly wasn't constant in the beginning, it implies that Fnet was not 0 initially.